everyone, and welcome to this evening session. And it's a very tricky situation where India and England are playing for World Cup semi-final match, and we are here learning Lean Six Sigma. Okay, doesn't matter. We will try to a little what you can say. Wrap up today's session a little early, and whatever remains we'll cover tomorrow. Okay, so what we'll do, I am targeting to complete our major phase Minitab exercises today, so that you guys also, I know a lot of people are watching the match as well. Today's attendance also is very low, so I can understand people either are traveling, not yet reached home, and second, they're watching the match. I know that a lot of people are watching the match. I'm also curious what happens. It's very important, critical match going on there. Okay, let's start with the recap. See, yesterday we have seen the define phase, the project identification, then we have seen the the SIPOC and stakeholder analysis, etc., etc., etc. Okay, so all these things will we have already covered. So today, today we will be covering our major phase, which we have already started. The theoretical part we have already started, the statistical part. So today we'll focus on the Minitab exercises, etc. I hope everybody has got Minitab with them right now available. Just give me a confirmation yes in the chat box. You have the Minitab, right? Everybody. Krish, can you just send the message on the mentor WhatsApp so that my team will give you the immediate Minitab access? It's very simple to have it actually. Yeah. So the number you must be knowing, correct? Just a second. 3055248. So everybody just now it requires laptop to install Minitab. Okay, laptop with simple Windows will do, right? It will not be installed on a mobile phone. Okay, if you have the laptop, you can do it. Otherwise, just observe whatever we are doing, and then you can do it later. Okay, just send the message, and my team will revert. Just follow the steps, and you will get it. Okay, so today let's start with the major phase, the remaining part of it, which is very important. First point is, once we start collecting the data, there is something very important definition we have to make sure that that definition is very clear. That definition is called as operational definition. Make a note of this. Operational definition is a definition, meaning the definition of from while data collecting, we want to maintain some standardization. I'll give you example of I'll share with you the example. Okay, yeah, Amlesh, please send the WhatsApp message on the number given. Okay, just send a WhatsApp message that I want Minitab, and then our team will revert on that. Now let's say, for example, all the airline companies, okay, like Air India, Indigo, and Akasa, and what are the other ones, SpiceJet, and all those airline companies, they wanted to check what is their on time takeoff. Okay, so Indigo, this is just an example I'm giving. Indigo says the moment my plane pushes back from the parking bay, for me that is called a takeoff time. Okay, Air India says no, the moment my plane starts to taxi towards the runway, that is called my takeoff time. Akasa says no, the moment the plane reaches to the runway, that is my takeoff time. And the SpiceJet says the moment the plane takes off from the ground, that is called a takeoff time. Now everybody calculates their own takeoff time. You cannot compare because that is not apple to apple. Everybody's understanding is different, and to make that understanding standardized, we use operational definition. So in operational definition, basically, people, if you have what you can say, send the message. So my team will basically give you the the update. Okay. So who will what you can say? Who will collect the data? What data will be collected? When that data will be collected? Where that data will be stored? So who, what, when, where, and and then how and how much. So all these basically all the questions we answer in the operational definition. Who will collect the data? What kind of data will be collected? When, meaning what will be the frequency of data collection? What will be the location from the data collection? Okay. How that data should be collected? Any procedure we have to follow? How much data in every time? Sample size, etc. we have to collect. So all these things basically are called as operational definition. Okay. Very, very important. Clear everybody? Just give me yes in the chat box. Are you clear with this? Operational definition meaning while we are collecting the data, because a lot of people are collecting the data, because we have multiple people in our project. So to maintain the standard understanding of which data to be collected, we basically define this very easily. That is called operational definition. All right. Superb, superb. Thank you very much for the confirmation. Okay. Now, once that is done, then the next part comes is measurement system analysis. Okay. Which we call it as measurement system analysis. What is measurement system analysis? Measurement system analysis is, which we call it as MSA. MSA, measurement system analysis. Now, what is the objective of doing measurement system analysis is, see, in our process basically, what we do in Lean Six Sigma is basically we reduce the variation, correct? We try to reduce the variation as much as possible. Now, in this variation, some variation is because of the what you can say measurement system. Okay. So if this is the total variation, some portion is because of measurement system, MS, measurement system. What is measurement system? The variation induced because of measurement system. Example, let me give you example. Let's say you have some pens, for example, and you want to measure the diameters of the pen. Okay. Now every pen to pen there will be natural variation, correct? Now that natural variation could be because of the machine, material, method, man, all these factors will be there. Along with that, in the 6M there is something called measurement as well, right? Now what is measurement variation? The variation induced because of the measurement system. Now we are using some vernier caliper or some screw gauge. Now because of which, because of some kind of variation can get induced, and that is called as measurement system analysis. I always give example of the weighing scale. Okay, when we basically use the weighing scale to weigh ourselves, correct? In that case, what happens is when you weigh yourself at your home, when you weigh yourself at your gym, and you weigh yourself at your doctor's place, all the three locations you will find a variation. Now this is not variation coming from because of your weight, but because of the weighing scale itself, and that is called measurement system variation. Now how do you quantify that measurement system variation? That's why MSA is there, to quantify the variation because of measurement system. Are you clear the objective? How much percentage? Now if it is below certain percentage, it is acceptable. If it crosses certain percentage, then it is not acceptable. And how to quantify that? That's exactly what we do in the MSA, measurement system analysis. So there are basically two parts. If you have continuous data, yes, if you have continuous data, then basically we do gauge R and R, GRR. And if we have discrete data, then basically we do attribute agreement analysis, AAA. So continuous data, we go gauge R and R. Discrete data, we go attribute agreement analysis. So all these continuous and discrete yesterday also we have covered, right? Which can be measured, it is continuous data, which can be counted, it's a discrete data. Okay, so in the green belt level, basically we cover only the basic part of it. Okay, in the black belt level, we cover the practical part of measurement system analysis, how the data has to be collected, how it has to be analyzed, all those details are covered in the black belt level. But in the green belt level, only the basics are covered. For example, let's say, what is gauge R and R? Gauge R and R stands for repeatability and reproducibility. Before that, this entire measurement system, there is a standard guideline which is published by AIAG. Just make a note of this. AIAG is a, it's a automotive action group basically. Okay. And this automotive action group is basically what you can say, produces the, just like ISO 9001, right? So we have this AIAG group plus this. So this is a group of the US led, what you can say, the automotive companies. Now apart from that, we have the another group as well, which is just a second, which is German group as well. Now they have published the entire thing, what you can say, together. Okay. Now this is what is there. Now AIAG, according to AIAG, basically automotive industry action group, by the way, automotive industry action group. Now this, according to them, what is repeatable? So what they say, you have to take 10 samples. For example, if I'm checking the diameter of the pen, so take 10 different pens, okay, and you multiply that. So every pen has to be checked by 3 times, 3 trials, and by 3 people or 3 quality person, or we call them as appraisers. So 10 multiplied by 3 becomes total 90 data points. That means, example, so let's say this is the pen. I want to check the diameter of the pen. Okay. So I will check it first. I will check it second. I will check it third. So 3 times I will check. Then second person also will check 3 times. Third person also will check 3 times. So every pen will be checked by 3 people 3 times. So every pen will be checked 9 times. So multiply by 10 is equal to 90 data points. Okay. And it will be randomized. It will not be, sequential. It will be randomized. Okay. Just to remove the bias out of it. And then we feed the data into software called Minitab, and Minitab will give us some numbers. Okay. Before that, let me just clarify what is R and R, repeatability and reproducibility. Repeatability meaning, just for our understanding, repeatability and reproducibility. Let me just make it very easy to understand. What is repeatability? Repeatability meaning same sample, with same equipment of measurement. Let's say same equipment meaning same vernier caliper, same screw gauge, etc., and same person. That means if I take the pen, same vernier caliper I use and measure the diameter, and I am measuring it multiple times. If I am giving the same results, that is called as repeatability. Ability to repeat the same reading is called repeatability. Okay. The second one is called reproducibility. That means same sample, same equipment, but different person. It's called as reproducibility. That means same sample will be given to the with the same equipment will be given to the different person. If both the different people are giving the same reading, that is called reproducibility, ability to reproduce. Now, how do I remember this? How do I use one simple trick. I use one simple technique here. Now, as human beings, to reproduce basically, we need different people, right? A male and a female we need, correct? So, I associate reproducibility with different people so that you can easily remember this. Repeatability, same people, same person. Reproducibility, different people. Are you clear? This is called repeatability, reproducibility. So we collect the data in this sequence, put them in the software, and software gives us some values. Now, in case of gauge R and R, we get a GRR value. Now, this is very interesting. You can just make a note of this. GRR value. If GRR value is basically okay, I'll just write here. If GRR value is basically between 0 to 10%, that's a best measurement system. If it is between 10 to 30, it is still acceptable. And 30 above, you can reject it. So 0 to 10% of gauge R&R value if your software gives you, that's the best system. 10 to 30% acceptable, and 30% above, you have to reject the measurement system. Okay, we have to basically identify why there is a more variation. And when it comes to AAA, I'll write here on this side, AAA has got a different value. AAA, everything remains same. You know, instead of what you can say, the continuous data, we have discussed just like pass and fail, male, female, no, go, no go. Example, if I give the file to the banker, and that bank officer has to accept the loan file or reject the loan file, that is called attribute data, right? So in that case, 10 files will be given to, and same file will be given to that person 3 times. Okay, so repeatability, reproducibility remains same. And in AAA, basically we find out kappa value. Here we find out GRR value. Here we are finding out kappa value. Of course, the software gives us. Now, in green belt level, we are just talking about the overview of this. In the black belt level, we go deeper into that, how to calculate, etc. Everything we will conduct. Okay. In case of kappa value, this is similar to that, which is just a little difference here. 1 to 0.9, it is the best system. If you are having between 1 to 0.9 kappa value, between 0.9 to 0.7, still acceptable. 0.7 and below, you can reject it. Again, it depends on which industry you are from. If you are dealing with a very precious metal like gold, let's say for example, there the measurement is very critical for you. So you can only accept up to 0.9 only. Okay, and if you are for you the weighing scale, etc., the measurement system does not matter huge, much, then you can go up to 0.7 value, kappa value. Okay, so this overall, what it does basically, it takes the data and check it quantifies what is the variation because of the measurement system. And that is what MSA is doing here. Okay, so continuous data, gauge R&R, discrete data, AAA. That's it. Otherwise, the procedure remains same. We have to collect the 90 data points, feed that in a software, and software will give us GRR value in the gauge R&R and kappa value in the AAA. Are you clear? Just give me yes in the chat box. So both are important for us to study, and the black belt level we will see the practical approach of this. Okay. Superb, superb. Now, let's start with imagine once we collect the data, okay, now we will start using our amazing software called Minitab, okay. So I'm just sharing the Minitab file in the chat right now. So first I'm sharing a Pareto chart, okay. Let's AAA. In case of AAA, software gives us the kappa value, the value which is called as kappa. See, kappa is nothing but just like alpha, beta, delta, gamma. Similarly, kappa is a Greek letter. Okay. So it gives us the kappa value, and on the basis of the kappa value, you have to check whether it is acceptable measurement system variation. If it is within the acceptable range, then we can collect the data from that measurement system. If it is beyond acceptable limits, then we have to make the correction in the system. What do we mean by make the correction? It can be calibration of the equipment, it can be training to the people, it can be identifying what are the other factors, okay, which are there. I'll give you classic example of kappa value here. One of the printing company, okay, this is very interesting. One of the printing company, their kappa value was coming very low, so the variation was very high. So what we found out, so we all gathered together and did the brainstorming, and what we found out was, meanwhile you can just open the file which I have given in the Minitab, okay. What we found out, some people, they were checking the sample under the white bulb, and some people were checking the sample under the yellow bulb. Are you understanding this? So there was a variation in the measurement system, okay. There was a little shade change, and because of which their measurement was going completely different, okay. So these kinds of detailed analysis you have to do if there is a variation in the measurement system, okay, clear? So let me also share my screen and let's go for. Alright, so we have this data of one of the exporter of the fruits, and he is getting some what do you say, complaints, customer complaints, okay. So he is exporting the peaches, and these are the complaints he is getting. So 100 peaches are bruised, undersized are 87, rotten and 237, etc, 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 235, sorry. So he wants to do a Pareto analysis of it. So go to stat, quality tool, Pareto chart. Everybody just follow this path, please. Once you open this file, now to open the file, you should have a laptop with Minitab installed into it. Then it will be easy for you to open this, okay. If you are traveling, if you don't have laptop right now, then you can just observe what we are doing, okay. Go to stat, quality tool, Pareto chart. This is the path we have to follow. Stat, quality tool, Pareto chart. See, Minitab requires a little bit of practice. More practice you do, better for you, better confidence you will become, confident you will become in navigating this tool, okay. See, we are doing it again and again and again, you will become master into that, okay. So click on Pareto. Now in the defect column, just select the problem, double click on the problem here, and frequencies, double click on peaches lost. Yeah, so go to stat, quality tools, Pareto chart, okay, follow this, or maybe you can just write this down, stat, quality tools, Pareto chart. Now in your study material, we have given you the screenshots of it, okay, so that you can anytime check that out. Stat, quality tools, Pareto chart, okay. Once you click on that, in the defects, see in these two columns, the defects are in problem column, right? So double click on problem, and frequencies, how many numbers are there? Those are in C2 column, right? Peaches lost, just double click on peaches lost. Now before clicking on OK, there is one small setting here. Combine remaining defect into one category. Now this particular option you have to exercise when you have more than 10, 20, 15, okay, more problems, more defects, in that case this can be exercised. But right now we have only hardly 6, right? So we don't want this option to be exercised. We just say do not combine. Okay, what it does basically, last 5%. So if I say combine the remaining defect into one category after 95%, okay, so after 95%, whatever remaining are absolutely very, very low impact making factors. So we combine them together and put them in the other category. Okay, put them in the other category. So right now we only have 6, so we don't want that to be exercised. So just click on do not combine and click on OK, and you will get a Pareto chart like this. Okay, clear? Everybody got this? Just give me yes in the chat box. Once you got it, just let me know. Done? Done. Very good, very good, very good. Okay, so you can see here, let me, okay, just a second now. So, so you can see the biggest contributor here is rotten, which is 53.3% contributor. So more than 50% is rotten fruits. Okay, and bruised is 22.7%. So if I combine them together, the cumulative percentage is 76.5. So you can see here, this one is rotten, which is 53.3%. Where it is written? Here it is written. Okay, and bruised is having 22.7% contribution. So 22.7% contribution. So if I add 53.3 and 22.7 becomes 76%. So this is called cumulative. This one, this is called cumulative percentage graph. So this is 53, then 76. If I add the next one becomes 95.7. Can you see here? So even if I consider these two, only these two, okay, so total is 76% here. If I consider 3, the total is almost 96%. Almost 96%. So if I focus on these top contributors and eliminate them from the system, I work on them, I do a project and eliminate them from the system, I can have 80 to 90% on my wastages can be saved. And this is the, what you can say, the main objective of Pareto chart. It basically gives us the focus area, the priority area. Are you clear? The Pareto chart, just give me yes in the chat box. And where can you use this? Yeah, where will you use this? Yeah, can you just share the screenshot of it? Just make a screenshot and put it over there. Have you selected the X and Y properly? Let's say, for example, look at this. Go back. Check in the defects you have selected problem and frequencies you have selected pitches. Have you done that? Krish, have you done that? Just give me yes in the chat box. Make sure this is done. Even if you select this, no, it is okay. You can just click on OK. And you can see here other category. After 95%, whatever comes will be categorized in other category. Okay. So this is how basically so when you have huge number of items, right, like 10, 15, 20, 25, then you can use this other category to categorize them into one bucket called other, because they are insignificant contributors. Our main focus is this. Yes, have you checked that? Have you checked defect mein problem and frequency mein pitches lost? Just have to make sure that. Okay, I'll send the file once again. and all these files are available in your this will be available in the hackathon as well, hackathon folder, plus it is available in your green belt curriculum as well. Okay, done. Can I get the confirmation? Clear hai? So this is now, where will you use this? Type in the chat box at least one use case. Where can you use this in your process? Pareto chart. Type in chat. Everybody type in the chat box, where can you use Pareto chart in your process? Very good. Internal project. If you remember, yesterday we discussed about, painting department, where the lowest yield was there. So there we can find out what are my projects, the priority projects, where we can use this. Very good. Apart from that, customer complaints and internal defects. Absolutely right. So you can prioritize customer complaints. You can prioritize internal defects. You can prioritize the, the machine downtimes. Okay, which machine is having the maximum downtime? Okay, that you can prioritize. A lot of things. Okay, not finding an option to share the screenshot on the chart. Okay. Screenshot, just take the screenshot, copy and paste, that's it, in the chat. Which I think should be available. Right now it is host and panelist only, so we can check that. Share to the mentor's number, is it? Okay. Okay, let me just check if, just give me a second, okay. Meanwhile, just open this file, meanwhile, which I have just given. Open this file quickly. Yeah. Just open the file, which is called process capability normal. Okay, just open this file. We will use this. Okay. Okay, just a second. So have you taken the same file, right? So yeah, I got your data, I got your graph. Now what has happened is, just follow this procedure once again. Stat, quality tools, Pareto chart. Okay. Defects, in the defects problems, have you done that? Just give me yes in the chat quickly. Krish, have you put defects mein problem? Double click on problem, defects mein. Just delete everything else, just in the defect, just put problem. Just give me yes. Quickly. Who is this? Rajesh, huh? So, very good, very good. Exactly. So, just defect mein problem and frequencies mein pitches loss. That's it. Stat, quality tools, Pareto chart. Remember this, stat, quality tools, Pareto chart. Click on that. In the defect, select the defect column, which is problem. In the frequencies, select the pitches loss. That's it. Yes, Rajesh ji, you have done a fantastic job. You have done perfectly all right. Okay, and then let it be, combine रहने दो and just click on OK. That's it. Problem को defect में and frequencies में pitches loss को select करो. Double click करना है. That's it. Double click on it, then click on OK. And you will get this. Got it? Just give me a quick confirmation. Yes. Done, done, and done. Guys, a little faster will be helpful. Okay, done. Chalo. Okay, so let's open the next file, which is the chocolate sample weight. Okay. Everybody open the file. Okay. If you don't have Minitab software, will not get downloaded. Okay. I'll just give it once again. Just click on that. If you have laptop open with Minitab, it will get downloaded immediately. So here we have the chocolate weights. Let's find out. Yesterday we have seen stability, normality, and all those things. No, not stability, normality. Although we have seen the yeah, no problem, no problem. See, we are not getting disturbed actually, but what happens is, then it should open, and the same Minitab, right? We have Minitab 17 right now. You have some other version also, this will not open. You have any other version, then it will not open. Same Minitab which we are using every day. Just give me the confirmation, yes. Okay, then it should open. There should not be any problem then. What challenge you are facing? The earlier file got open, right? But this is not opening. Okay, meanwhile, let's say first thing, okay, earlier got open and this is not opening. Anyways, let's have a look at this. For example, let's say I want to find out the graphical and statistical analysis. Okay. So go to Stat, Basic Statistics, Graphical Summary. Stat, Basic Statistics, Graphical Summary. Just follow this. Go to Stat. The first option is Basic Statistics. In that, third option is Graphical Summary. Select that. Select chocolate weight in the variable and click on OK. That's it. You will get this kind of a diagram. Now, just for your information, this is histogram. Everybody knows this. Just give me yes in the chat box. Okay, got it? Very good. Sachinji got it. Okay, very nice. So everybody got this, right? Stat, Basic Statistics, Graphical Summary. So the first graph is histogram. Everybody knows, right? Just give me a quick yes in the chat box. This graph, this one is called as box plot. Okay, this is called as box plot. Now, box plot you have not seen, but you have seen. Let me explain you this. Histogram you all know, right? The bell-shaped distribution, etc. of the same data. Now, box plot is nothing but, okay, this is the lowest value. This is quartile 1. This is quartile 2. This is quartile 3. And this is the highest value. Have you seen this yesterday in median? Just give me yes in the chat box. You remember the median calculation we learned yesterday? This can be denoted in this kind of a box plot. Braid example. Yes, exactly. Absolutely right. Okay. So this is basically a box plot. Over here, we have seen mean yesterday. Standard deviation, variance, correct? N is equal to number of data points. Then here minimum, first quartile, second quartile, which is median, third quartile and maximum value. We have seen yesterday all these things. What we have not seen is skewness and kurtosis. What is skewness? Skewness is how much is your data skewed. If it is perfectly normal distribution, perfectly normal, super perfect normal, skewness will be 0. But no data will be perfectly normal distribution. Okay, so there will be some kind of skewness, and this is what is denoted. Kurtosis is nothing but the pickedness of the data. What is pickedness of the data? For example, some data will be like this, flatter distribution. Some data will be like this. Okay, all are normal distribution, but what is the difference is the pickedness. Okay, some are flat, some are normal, some are very much picked. Okay, that is shown in the what you can say, this kurtosis. Kurtosis is about the pickedness. Okay, when it is perfect normal shape, the kurtosis is also 0. Okay, when it is becoming a little flatter, it becomes negative. When it becomes more what you can say, leaner and picked, it becomes positive. And at the equilibrium exactly standard, which is kind of 0 kurtosis. Okay, nonetheless, we are not using this right now. Then this is something very interesting called Anderson-Darling normality test. What is Anderson-Darling normality test? Anderson-Darling normality test is whether this data is normally distributed or not. If the p-value is greater than 0.05, it shows the data is normally distributed. If the p-value is greater than 0.05, the data is normally distributed. Are you understanding? Okay, so this is actually one kind of a hypothesis testing only. All right, so tomorrow I will cover a little bit of hypothesis testing for your understanding, where we will touch upon this topic as well. Okay, and on the other side here, okay, see, do you remember the descriptive and inferential statistics? Just give me yes in the chat box. So this is called as descriptive statistics, and this is called as inferential statistics. What does it mean? It says 95% confidence interval of mean, for mean. What does it mean? For example, let's say for this sample of 120 chocolates, the actual mean is 42.106. This is a sample mean. Okay, now what the statistics is, what this software is saying, what about the long term? If we keep on collecting the data for a very long time, for 1000, 2000, 10,000, for the longer duration, the mean will be between 41.8 to 42.4. This is called interval, confidence interval, 95% confidence interval. So with 95% confidence, we can say that the mean will be between this point and this point. Same goes with median. Okay, now the right now median is 42.1. This is about the sample median. If for a longer duration of time, for the population, the median will be between 41.5 to 42.3. And same goes with standard deviation. The current standard deviation is this 1.645, and over the longer duration of time, for the population, the standard deviation will be between 1.4 to 1.8. This is, we are predicting, we are inferring about the population behavior, and that is called inferential statistics. Are you clear with this? Just give me yes in the chat box. Clear? And of course, there are formulas to calculate it. Okay, and we have given a lot of exercises about it. Yes. We'll check your Pareto analysis. Okay, no problem. Done. Just give me quick yes in the chat box. Everybody got it? Just give me yes. Everybody got the same understanding of it? Yesterday we have seen all the theoretical part of it. Now we are doing the practical application of it. Okay. Now let's do one thing. Let's do a time series plot. Everybody just go to graph and go to time series plot. Follow this graph and time series plot. click on graph and time series. For the same data, we are clicking on time series plot. Go click on graph, and just from the bottom, I think fifth one is time series plot. So simple is by default, just click on OK. Select chocolate weight and click on OK. Don't do anything else. Everybody got this? This is like our, stock market trend. Every day, our Nifty 50 index, Sensex of our BSE or NSE ka, yes, up and down. So here you can actually identify the patterns and the trends of the data. Okay. Here if you observe, you have to investigate. If you remember statistics definition, data convert into information. Now this is information for us. If I give you only numbers, you will not able to comprehend it. Now I am giving you the trend. Okay. Okay. You are a technical analyst. Okay. Fantastic. Fantastic. Superb. Now I have given you the trend. Now you have to investigate what is wrong here, why there is a peak and why this valley and why there is a huge difference between almost consecutive data points. Okay. Here also you will see similar kind of trend in the process. Okay. Almost consecutive data points are going towards the extreme ends of the process. So you have to investigate why this variation is occurring. Along with that, if you see, if I mark a kind of a line here, just observe this. Just beyond this line, the variation is very high. And before this line, the variation is very low. Can you see here? Are you observing this? Just give me yes in the chat box. So this has to be investigated. What has happened at 50th data point onwards? Why the process has suddenly become more variation prone, which was not there earlier? That has to be actually questioned. And that is the role of that is the actual idea of the analysis. And from this analysis, you get the wisdom. So statistics is data converting into information converting into wisdom. That is the end point, end goal in this. So entire, in this entire exercises, your actual understanding should go to the next level. All right. Now, just stretching this exercise, we will do something called stability check or control chart. Okay, the same graph, we will add a few lines. Okay, how do you do that? Go to stat, control charts. Everybody follow this. Individual control chart, individual. Everybody follow this path, please. Stat, control chart, variable charts for individual, individual. We do that in our system. Okay. Peak consumption analysis. Okay, very good, very good. So we have to identify what are the factors contributing to the peak and what are the factors which are contributing to the valleys. And that is where you get the wisdom. Very good. Along with that, there are trends as well. Okay, for example, look at this. If you observe, this is the pattern. Can you see a pattern here? Data coming down. Okay. Plus, I can see the pattern here. Can you see a pattern? The process is shifting upwards. Can you see? All these are the trends and patterns. Can you see this is the pattern? Now let's say this is the pattern going down. So this is where process is going down. This is the process. This is the process where this is going down. This is the process which is going up. So you have to basically identify these patterns and investigate these patterns. Okay, that is the main objective. All right, coming back to the control chart. Stat, control chart, variable charts for individual. Just select chocolate weight and say okay. Head and shoulders pattern. Okay. Now the same pattern data. Now we have got three lines here. One is called the mean line, which is X bar, the average. Other one is called upper control limit and then lower control limit. Now, what is upper control limit? The formula is X bar plus 3 times standard deviation, and lower control limit, the formula is X bar minus 3 times standard deviation. Okay. Example, let's for the simple calculation. If let's say average is 42, let's make it very simple for our calculation. Average is 42 and our sigma is 1. Okay. In that case, X bar plus 3 times standard deviation, meaning 42 plus 3 into 1, because standard deviation is 1, right? So 42 plus 3 is equal to 45. So in that case, my UCL will be 45. And in the other side, 42 minus 3 into 1, which is 42 minus 3 is 39. So my LCL will be 39 in that case. Are you clear? 45 will be my upper control limit and LCL will be 39 in that case. Clear? When X bar is 42 and standard deviation is 1. Of course, we don't have to calculate it manually. Software will calculate for us. But we should understand what is the mathematics behind it. Now, anything which is within this variation, within this band, it's called as common cause variation. Common cause variation. Okay. And anything which goes beyond this, for example, can you see this point is just on the boundary line. Imagine if it goes beyond this, it is called as a special cause variation. Special cause variation. So within the band of upper and lower control limit is common cause variation. Beyond that, it's called special cause variation. Why it is so important for us to understand? To check whether the process is stable or not. This is called as stability check. Okay, we use Bollinger band, which is 2 standard deviation. Very good, very good. Superb. Are you understanding this? Okay, so this is 1 standard deviation, 2 standard deviation, 3 standard deviation. So, according to the Walter Shewhart, who is father of statistical process control, any process which flows within plus 3 and minus 3 standard deviation from the mean is a stable process. Stable meaning predictable process, predictable. We can predict the behavior of the process very easily. That is called stable process. Are you understanding? Now, so this is called as a stability check. Yes, exactly. If it goes beyond upper or lower control limit, that is called as special cause variation. I'll give you example. When you go to office, there is 5-10 minutes variation. That is called common variation, because of the routine traffic, because of the the bottleneck in the lift, etc., or your wake up time, preparation time. This is common variation. But one day your tire got flat, your car's tire got flat. Okay, that day you reach 1 hour late to the office, and that is a special cause variation, because that's a special. It does not happen every day. So common cause variation happens every day. Special cause variation happens once in a while. Okay. So 6 sigma. This is a very interesting statement I'm making. To identify and eliminate special cause variation, you don't require 6 sigma. Listen to me very carefully. To identify and eliminate special cause variation, you do not require 6 sigma. But to reduce common cause variation, you require 6 sigma. How many of you got it? So special cause variation, you can use very much common senses to identify and eliminate it. But common cause variation, our objective is to reduce the common cause variation and bring it to the center as much as possible. See, we cannot eliminate common cause variation. We cannot eliminate common cause variation, but our role is to reduce and bring it to the center. I repeat the statement once again, listen to me very carefully. We need 6 sigma not for the special cause variation. A lot of people say, okay, this is where we have to focus. This is very obvious. Okay. So this is very obvious. Your tire got flat. You need to make sure that next time tire does not get busted or whatever it is. You have a separate arrangement for that. But it's common cause variations. Now it is very difficult to identify the patterns and the trends, and it is very difficult to identify. That's where we use the 6 sigma DMAC principle to basically reduce the common cause variation. The main objective of 6 sigma is to reduce the common cause variation and reduce the variation as much as possible. That is the objective. Okay, not to eliminate special cause variation, because it does not require that much of critical thinking, and because it's very obvious causes are there. You can easily identify and eliminate them. Clear? Everybody with me till now? Just give me yes in the chat box. Very good, very good, very good. Okay, now understand this. So we have done See, remember S, N and C as a sequence, which is called stability, normality and capability. What is that? Stability, which is nothing but control chart. Write this down. Normality, N for normality, which is nothing but Anderson-Darling test, AD test, which we have already done, right? AD test, p-value greater than 0.05, that the data is normal. And C is nothing but capability. So we have already seen the normality test, we have already seen the stability check, stability, normality, and now we are doing process capability analysis. Now for the process capability analysis, we need specification limit from the customer. Okay, so in this case, imagine the specification limit is between lower specification limit is around 36 and upper specification limit is around 48. Okay, and target is 42 is a target. All right, so this is the specification limit given by the customer. So let's find out whether my process is capable or not. How do I find out that? I'll go to stat, quality tool, capability analysis, normal. Stat, quality tools, capability analysis, normal. Stat, quality tools, capability analysis, normal. Okay. Now, once you click on that, in a single column, select chocolate weight. Subgroup size, just select one. Okay. What do you mean by that? One meaning, subgroup size one meaning, we are saying that we are just selecting one chocolate at a time. Subgroup meaning the group of samples basically. Okay. So let's say subgroup size is 1. Here lower specification is 36, upper specification is 48. Write this down. Don't click on OK yet. Go to options and do a small change here. Go to option and instead of CP value, just click on benchmark Z. Instead of CP value, just go for benchmark Z. All right. Just click on OK and click on OK. Now you have got this graph. Everybody got this? Just give me yes in the chat box. Everybody got it? So single column में chocolate weight, subgroup size 1, 36 lower specification, upper specification 48. Go to option, select benchmark Z, click on OK and click on OK and you will get this. Okay. Now what does it mean? You can see here, this is my short-term process capability, which is from the sample, which is my descriptive statistics. Okay. Which says benchmark Z. This is 3.93. When my benchmark Z bench is 3.93, that means my process is 3.93 sigma process. Very close to 4 sigma process. Okay. Are you clear? So this is how basically process capability analysis is done. So this is my lower specification limit, which is 36, upper specification limit, which is 48, and this is my data. Okay. So right now it is very close to 4 sigma process. Now you have to reach to next level, maybe 4.5 sigma or 5 sigma process, etc. And that is where, so you reduce the process variation and your process capability will increase. That's how basically we calculate this. Clear? Everybody just give me yes in the chat box. Super clear? Very good. The moment we find out process capability analysis, so that is the end of our, what does it mean by 4 sigma? It means 4 sigma meaning, just for our understanding, okay, imagine a process where, let's say this is a process and this is the mean, okay, x bar, and this is my, let's say, upper specification limit. Okay, so what do you mean by 4 sigma process? If my standard deviation, imagine, let me put some numbers here, 42 and this is, let's say, 46. I'm just giving you very raw numbers. Okay, so imagine my standard deviation is equal to 1. So when my standard deviation is 1, I can fit 1, 2, 3 and 4 times standard deviation here, right? Because my standard deviation is 1, right? So when my standard deviation is 1, I can fit 4 times standard deviation between my upper specification limit and my mean. Same goes with the lower specification limit as well. If the lower specification is here, LSL, okay, it will be at what, 30, let's say 30 what, it will be around 38 for example. Okay, I can fit 4 times standard deviation here because my standard deviation is 1. So between x bar and USL or between x bar and LSL, I can fit 4 times standard deviation. That is my 4 sigma process. Clear? If I reduce, let's say for example, imagine I reduce my variation and my variation becomes like this. Now my sigma has become 0.8. Imagine that. Okay, earlier it was 1. Now I have reduced my variation. My sigma becomes 8. Now I can fit 5 times standard deviation. 0.8, 0.8, 0.8, 0.8, 0.8. I can fit 5 times standard deviation, and that is what that is called as 5 sigma process. Clear, everybody? Just for your information. How many standard deviations I can fit between my specification limit and my mean, that is defining my process capability. More standard deviation I can fit, the moment I can start fitting 6 times standard deviation, that becomes my 6 sigma process, which is very difficult to achieve, by the way. Okay, very interesting, isn't it? Superb. Okay, any question you can just put it in the chat, and I will try to answer this. Okay, now see, once I identify the process capability, my next job is to identify the 6 sigma means, no, it is 99.99966%. That is called 6 sigma. It's not 100%. Yeah, 99.99966%. That means 0.00034% will be defect. Okay, when you say you want to fit number of standard deviation between LSL and X bar. So for example, let's look at the same example. Let's take a same example of same chocolate example lete hain. Okay, let's say this is the mean, which is 42 grams. Okay, now this is X bar. Okay, now customer says I will accept the chocolate within 48, that's what we have seen, 48 grams and 36 grams. Okay, this is what customer expectation is. So this becomes my lower specification limit and this becomes my upper specification limit. Okay, now yesterday we have seen standard deviation formula, calculation formula, D1 square plus D2 square plus D3 square. Remember that, right? So all the chocolate distance from the mean, I will calculate, square them, I'll take the average and then take the square root of it. Okay, standard deviation basically. Simple standard deviation understanding is nothing but the average distance from the mean. Okay, let's forget about it as of now. Imagine I have the process like this. So this is my process. I've collected the data, I have made a distribution. Okay, now I calculate a standard deviation. My standard deviation comes, let's say, 2. Okay, now when my standard deviation is 2, between, now understand this, my sigma is 2, so between 42 and 48 I have got distance of how much? 6, right? 6. So I can fit actually 2 and 2 standard deviations here. That means this is 1 sigma, this is second sigma, and this is 3 sigma. Because between 42 and 48, we have got 6 grams distance and my standard deviation is 2 grams, right? So I can fit 3 times standard deviation between my upper specification and my lower specification. Are you understanding this? Got it? So if I can fit 3 times standard deviation, that makes my process 3 sigma process. How many of you got it? Just type yes in the chat box. Exactly same process. My sigma is 2 grams. Now I can fit 3 times standard deviation in between specification, upper specification and my mean. I can fit 3 times standard deviation. That is called a 3 sigma process. Clear? The same goes with lower specification as well. You can select either. Okay, either upper or lower. Both sides you can fix. Now imagine I have made lot of 6 sigma project and now my process is very thin. Now my process has become very lean. Now my process has become very lean, my standard deviation will reduce. Let's say my standard deviation sigma is now 1 sigma, or sorry, 1 gram, because standard deviation has the same unit, right? Now, when my standard deviation is 1 gram with the same specification limit and same X bar, imagine. Okay. Now I can fit between 48 and 42 within 6 grams ke distance, I can fit 6 times standard deviation because my 1 standard deviation is equal to 1 gram. I can fit 6 standard deviation, and when I can fit 6 times standard deviation, that is called as a 6 sigma process. How many of you got it? The moment I can fit 6 times standard deviation between my specification limit and my X bar, that is called my 6 sigma process. Are you clear? But customer can accept whatever more, not less. If it 100, customer can accept. No, see, that is, for example, when we say 100%, that means 100% of your product is basically within the specification limit. That is called 100%, but practically it is not possible. No process in the world can produce for a long term, or for a short term you can produce, but for a long term, no process can produce 100% accurate and precise product. So there is a variation which is bound to happen. Some kind of defect is bound to happen. Okay, and that's where we are measuring. If we can reach up to 99.99966% of accuracy, that is called 6 sigma level of performance. Okay, so it's a long way to go, by the way. Okay, so this is called as process capability. Okay, I hope this is clear now. Very good, very good. Now, once we identify the process capability of the current process, okay, then we come to the analyze phase to identify what are the causes and the root causes of the problem. Okay, now here in the analyze phase, basically there are two approaches. See, we are talking about lean and 6 sigma, right? So there are two doors which gets open here. One is called a lean door and other is called a 6 sigma door. Okay, there are two approaches, two analysis phase mein two ways are there, two doors are there. Okay, so in lean door, it is also called as a process door I would say, and 6 sigma door is also called as a data door. Just make a note of this. In the process door, what we do is we use tools like process mapping we use. Okay, then we use value stream mapping, VSMs we use. Then we use the VA NVA analysis. Of course, some of these tools we are going to learn tomorrow. Then Teamwood we do in the lean approach. Teamwood everybody knows, right? VSM is value stream mapping. On the other side, Six Sigma door, we do fishbone analysis, which is also called as cause and effect analysis. Then we do root cause analysis, which is after that, which is also called as why analysis. After root cause analysis, we do validation of the root causes, and that validation is done with the help of hypothesis testing and regression correlation, etc. Okay. So lean process door approach, where process map, value stream map, VA, NVA, Teamwood, etc. And Six Sigma data door approach, fishbone, root cause analysis, etc. Okay. So in which, of course, fishbone you know, root cause analysis you know, Teamwood you know, correct? We are going to talk about, focus more about hypothesis testing. What is that? We'll practically understand it. Regression, what is that? How we can use that? VNV analysis can be used. How? Okay, those things we will basically study further. Okay, in the analyze phase. So what we'll do right now? Okay, what we'll do right now? I wanted to continue the session, but okay. Lot of you, I know the match is also in the very exciting mode right now. What we'll do, we will stop here today and we'll continue the discussion tomorrow, okay, for the analyze phase, and we'll focus more on hypothesis testing, regression, practical, etc. Okay, is it okay for you? Just give me yes in the chat box. Yes, you can also enjoy the match and I can also enjoy the match, because otherwise yeah. Okay, yes, very good. Very good. So yeah, Krish, meanwhile, can I just open your Minitab, that Pareto wala thing, okay? And let me share my screen quickly once again. Just follow the path and let's see how you can. Okay, so India is doing good, huh? Okay, but again, it's very dangerous team. England team is very dangerous. They have got a very deep batting lineup. Okay, so even 220 also will be very, it's not confident team nahi, because see, Wankhede is very small ground, okay, and yeah. CPK and PPK. CPK is a short-term process capability, PPK is a long-term process capability. That's the only difference. Short-term meaning, let's say you are one shift data, one shift process capability. You collect the 100 sample, that is a process, short-term process capability. Long-term meaning 1 month, 1 year, okay. That kind of a long-term process capability is a PPK, okay. Just let me know 1 sigma to 5 sigma percent. It's not percentage. Sigma is different, a percentage is different, okay. Sigma is different, percentage is different. Percentage is, for example, yes, okay. There is a table, if you remember, in the yellow belt I show, 6 sigma is equal to 99.99966 percentage. So there is a connection between that, and in your green belt, no, we have got that percentage calculation also, okay. Yes, CP and CPK available in the Six Sigma course material. Yes. What is LP? What is LP that? CP is the process capability index basically. Long term and CP, CPK, PP, PPK, everything is there in your curriculum. You can check out. That must be there in the CP, CPK is there in the green belt as well, but PP, PPK is there in the black belt. Okay, you can check out that. Short term, long term. So short term is covered in the green belt level, long term is covered in the black belt level. You can check out. Now, yes, so let's say this is the data for us, okay. Krish, just for you, now you go to stat, just follow exactly what I'm doing. Stat, quality tools, Pareto chart. We'll go one by one. Yes, done. In the defects, just select problem. So I'm just removing this first of all, and let me just. Okay, in the defects, select the problem, and in the frequency, select the pitches lost. You have exactly same. Now nothing is in between, right? Okay, just go to option here. Anything else change? I have not done anything else here. The data is same, right? Problem and the pitches law, the data is same. You have the same data, right? Or some other data. Okay. Defect into, so combine defect into one category, that does not make any much difference. Okay. You are not selecting in by variable, right? By any chance? Frequency में ही select करना है, not in by variable. And frequencies in pitches lost and this one in column, problem only. Yes? Click on OK. By variable में if you are putting, then that might, you might get some error over there. So just defect and frequencies and just click on OK. Do not put anything in by variable. And just click on OK, you will get this. Click on that. Got it? Fantastic. So I think it was a by variable wala problem. Superb. Okay, chalo. So we'll just close this session today. Okay. We'll continue our discussion in analysis phase and we'll focus more tomorrow on hypothesis and regression, etc. Till the time, enjoy your game and wish our team goes to the final. Okay. Bye bye. Take care. Keep learning. Keep growing.